Welcome to everyone. So this is the continuation video of the mathematical modeling series. Okay. So in the previous video, what we discussed is we discussed about the conversion of the mathematical modeling from a mechanical system towards the electrical system only. Okay, there is nothing will be there in the mechanical system. What we all considered is we considered a mass and a spring and a damper. Apart from the three things, we not considered anything. So there is only the mechanical system which is converted into the electrical system. But in this video, what we additionally we are considering is we are considering the rotational part, because the only mechanical part is not even considered. So we are including another part into that one. Then what will happen? What is the equation will happen? Okay. So in this video, what we are going to discuss is mathematical modeling of a physical system. Again, it's a physical system only, but the topics to be covered is mechanical rotational system is converted into the electrical system with respect to mathematical modeling. Okay. So most importantly, what we need to understand is the mathematical modeling of a equation. In the mathematical modeling of an equation, mechanical rotational system, in this you can see the close analogy between the mechanical and electrical system. So whenever the electrical and mechanical systems will be there, then automatically what you are having is you are having the multiple equation formats will be there. That means with respect to the force will be there, and the next one is related to the velocity, force, force, velocity, and mass, and damper, and spring. So these all things will be included when we are considering into the mechanical and rotational system. So then automatically it will happen. So then here what will happen is whenever you are converting a mechanical rotational system into electrical system, the quantities parameter will be changes, as you are already seeing here. So what I am saying is, so if you see, the force is converted as voltage, that is a electrical parameter, but the force is related to the mechanical parameter. In the same way, the velocity will be converted into current. Okay, force and velocity, how they are linearly proportional, and the same way voltage and current also they're proportional, sorry, inversely proportional. And the next one is mass will be converted into the inductance. Okay, mass, so whatever the mass is there, that will be converted into the inductance, and whatever the damper is there, that damper is converted into the resistance. So and finally what we are having is the spring, which is acting as a force. So here that force is considering as the inverse of the capacitance. Okay, so if we see the total whatever the things is there, that means the force that equal to F equal to ma. In the same way, mass, the mass, and the damper and spring. In the previous video, what we discussed is we only consider only these three. That means mass, damper, and spring. We are not considering the force. We are not considering the velocity. So now we are including these two parameters into the system. Then automatically what will happen is it is becoming a mechanical and also a rotational system. This what will happen is whenever you are considering this all the things into one parameter or one equation, then automatically that mechanical rotation system will be converted into the electrical system. Okay, so next we will see the what exactly the applications, because wherever the applications is there, so we need to understand where exactly this will be using in our electrical terminology or wherever it will be. So applications are so the applications will be related to the, sorry, due to this video some overlapping, uh, ignore that one. So applications, the transfer functions are widely used in automotive suspension systems, and the next thing is robotics and vibration analysis. If you see the robotics, which is having some movement will be there, automotive suspension systems, here some force will be there, mass also will be there, and the vibration, here we are having some additional of the movement of the things also will be there. So these things where we are having both mechanical also there and also rotational also there. So regarding that one, we need to consider that one. Accurate models allows us to design the effective controllers like PID and lead lag compensators, because whatever the controllers are there, as we already discussed about the controllers in inside the controllers, what the type of compensators, that means if we are having a 1 plus means, if we need to reduce that one means we need to something to minus that one, and then it will be equals to the 0. That means the error will be becomes 0. So that will be happens there. So that type of compensators are called PPI, PID compensators. Most popular one PPI, PID controllers, and also PR also will be there. And after that one, the lead lag compensator. This lead lag compensator is also, when it comes to the state space equation, it will be very much useful when we are designing one system or one control equation. Okay, thank you.